Good morning, anatomy classes. This is your third lecture for Chapter 16 on the excretory system. As you can see behind me, there's a lot of busyness. And typically, this is a lecture that when I do this in class, I spend probably a day and a half, 2 days on. And I'll probably do the same thing here. I'll probably leave this up, and I'll probably start the next lecture with an explanation of this again. Now, what are you looking at, I guess, is the question that I want to ask you first. I want you to kind of ponder and think about first. This is a nephron. Now, I've taught this before, and I've asked students, even after the test is over sometimes, like, well, they memorized everything that goes on here, they understand it, and then where is it? And they'll look at me blankly. So I want to make that clear first. The nephron is located in the renal cortex, the very outside layer of the kidney. And I say the nephron, there's 1 million of these per each kidney. So these little structures, this little snake-like structure that you see here with a lot of vascular association, there are 1 million of these per kidney. These are the functional units of your kidney. This is where filtration and the other processes that make your kidneys do the things that kidneys do, this is where they're located. So, and this is what they look like. This is a schematic. This isn't exactly it. It's not green, and it's, you know, there's a lot of stuff going on here, but this is a pretty accurate depiction of the shape. It's a tube, and it's surrounded by a capillary network, just like all the other things that we've talked about over the last few chapters. So what I'm going to do over the next 5, 6, 7 minutes is I'm going to go through what happens to your blood as it flows around the structure and as it is separated by the structure. So let's start with a branch of the renal artery over here. Right, I have a branch of the renal artery drawn. Remember, the renal artery is the artery that supplies the kidney tissue and the kidney cells with blood. So the renal artery is going to bring blood into this area right here. And what that looks like, it's almost like a ball of yarn. It's a knot. It's how it's literally described, as a knot of capillaries. It's called the glomerulus. Glomerulus. I don't have that written on the board anywhere. I will be sure to put that in your line of questioning that you'll get following this lecture. It's called the glomerulus. In the glomerulus, obviously, it's just a big knot of capillaries. So what's happening here? And, you know, I've had students before describe this as looking like something like a snake. What this is the first part of the nephron, and it's almost encompasses or encloses this ball of capillaries. What's happening here is that blood pressure is forcing fluid from the bloodstream through this wall of this nephron into what is called the Bowman's capsule. The Bowman's capsule is the head of the snake, so to speak. All right? So what you need to understand at this point is that when we have this physical force, the blood flow, the blood pressure, which is why blood pressure is necessary. Your kidneys will fail if they don't have adequate blood pressure because they won't be able to do their job. Blood pressure is important in that regard. Too much blood pressure, you can see what would happen. This whole structure will deteriorate. I'll talk about that in future lectures. So when we have the blood flowing into this area, what will happen is that mechanically the fluid portion of the blood and a lot of things that are dissolved in the blood are going to push their way into the nephron. What has to stay behind, what has to remain in the blood are the red blood cells. If red blood cells start forcing their way into the nephron or the tissue of the kidney, then you're going to have problems. It's blood in your urine. That's how it's usually diagnosed, that's an issue. There's too much force or the nephron itself's breaking down. So think of it this way. You know, maybe since you've been home over the last couple of months, you know, your parents or someone's asked you to, clean out your toy box. I'm not implicating anybody in having a toy box. If you do, that's fine. Throw everything out on the floor. All right, everything out on the floor except for the toy box. You hold the toy box back. Now, that's like the red blood cells. They have to stay back. But everything else gets pushed onto your floor, and that's pretty much what's happening here. All that's in the blood, outside of the red blood cells and some other items, are going to get forced into the Bowman's capsule. Now, when that happens, basically we've thrown out some good stuff and some bad stuff. So I don't want you to think of your kidneys at this point or your nephrons at this point as just taking all the bad stuff out. There's a lot of good stuff in here. And at this point, we don't call it urine either. So if you were to go into this Bowman's capsule, open it up, take the fluid out of there, that's not urine. It's called the filtrate because it's been filtered. That's what the Bowman's capsule does. It filters. And you can see I have a key up here that kind of tells you what's happening. So step number 1 with the Bowman's capsule is filtration. Now, in that filtrate, there are some wastes. There's a lot of water. and there's also some nutrients, some things that your body's going to want back. And that takes us to the next step. So it's kind of like playing Candyland or another board game where we're going to kind of move along the trail here. Now your filtrate's going to move up into this region here called the proximal convoluted tubule. I know that's a big word, the proximal convoluted tubule. We've learned these words already, though. Proximal means close to. So it's close to the Bowman's capsule. Convoluted means twisted, and that's exactly what it is. It's kind of a twisted path. Tubule is a tubule. So at this point, what's going to happen is that materials that your body wants back, things that are in that filtrate, remember all the toys that get thrown out, you have to throw some of them away, you keep some of them, put them back in your toy box. All right? So what are we going to put back into the bloodstream here? We're going to reabsorb some glucose. Glucose, obviously, is our energy source. We're going to take some amino acids back. Maybe some salts, like sodium, that we need. There's a lot of examples. I almost used the word million, but there's a number of different things we could say here. Whatever the body needs at that point, it's going to retrieve. And that's based on what you've eaten, what kind of shape your body's in, what electrolytes you've lost. You're going to pull that back, and it's going to go back into the bloodstream. And you can see I've drawn the red lines around here. Those are just capillaries. So that's going to flow back. It's going to be reabsorbed into the bloodstream. And again, that's the stuff that your body wants back. That's called tubular reabsorption. And that's step number 2. So again, we're going to take some things back out of this filtrate. So again, let's follow the pathway. And we're going to go down into this direction, into this big loop, this very conspicuous looking loop at the bottom here. It's called the loop of Henle. The job of the loop of Henle is to reabsorb water. So if you are at a point in your body, your homeostasis, maybe it's a little out of balance, maybe you just went for a long jog, maybe it's been a hot day, you haven't had a chance to replenish your fluids, your body's going to reabsorb that water that got pushed into the filtrate. It's going to pull it back out into the capillaries and return it to your bloodstream. And that's, again, you can see this pathway going back to the renal vein. So all these things eventually will get returned back to your bloodstream. They get reabsorbed. The job of the loop of Henle, this region right down here, this conspicuous looking loop, is to pull water back out of your blood if you need it. Now, if you've had a gallon of water over the last 12 hours, you're just sitting drinking water all day, you're preparing maybe for a race or just because you like to drink water, your body doesn't need it, your body will let it go. It won't reabsorb it. Again, this is all based on, there's no set what's going to happen here, so to speak. It depends on the state of your body. So if you're dehydrated, yes, you're going to reabsorb water. If you're not, if you're super hydrated, your body's just going to keep that water in the filtrate. It's not going to reabsorb it, put it back into the bloodstream, and it's going to continue on. Now, think about the state of your urine. If you're dehydrated, your urine is going to be very concentrated. It's going to be dark or yellow. If you're in a state where you've had a lot to drink, a lot of water to drink, your urine is going to be what's called dilute. It's going to be almost clear. That's because it's going to be a lot of water compared to the other things that are dissolved in it. All right, so let's take our next step. We're going to go up here, and I probably didn't draw this as well as I should have because this is also a convoluted tubule, but this is the distal convoluted tubule. Distal means far away or distant. So this is this region right here, distal convoluted tubule. And what happens here is a process called tubular secretion. This is the body's last chance to get rid of things that it doesn't want from the bloodstream. So whatever didn't come out in the filtrate here, your bloodstream has a chance to dump some things back in. It's kind of like the garbage truck pulling up to the curb outside of your house and you realizing that you still have a few things that you want to get rid of. This is the body's last chance to get rid of some waste from the bloodstream. So say you have a high concentration of ions of some type, maybe something you ate was salty, maybe your blood's a little acidic, we can dump off some hydrogen ions. That's what's going to happen here. So the direction that we're going to be moving here is we're actually going to be moving stuff into the filtrate from the bloodstream into the distal convoluted tubule. So over here in the proximal convoluted tubule, you're going to be taking stuff out of the filtrate back into the blood. Here we're going to be taking stuff from the blood and putting it into the filtrate. And it's still called filtrate at this point because there's still interaction with the bloodstream. Now, once we pass this last section of capillary right here, just put a little dotted line right here. Once we pass that last section, this is called the collecting tubule right here. That collecting tubule is right at the border of the renal cortex, which is the outside layer of the kidney. And again, remember, there's a million of these doing this simultaneously in your kidneys. And between the renal medulla. The renal medulla is the middle section of the kidney where we collect the urine. So once you get past this point, It is what it is. If you're in the urine at that point, if you're some kind of substance, you're going to become part of the urine. There's no taking it back. It can't be reabsorbed by your body. You can't add anything to it. It now is just going to drain into the kidney, into the renal medulla, into the renal pelvis, which is that central structure where the urine collects in the kidney before it leaves, and then into the ureter, into the bladder, and then out through the urethra. So, again, we're filtrate. We're reabsorbing water, secreting any last-minute wastes here. Now we have urine at this point in the collecting tubule. We're in the center of the kidney, or getting closer to the center of the kidney, renal medulla, and then eventually this will be leaving. So at this point, again, once we get past here, it's filtrate here, filtrate all over here, and then in this section of the tubule, it's urine. I just said a lot. I don't even know how long I've been talking, but I've just said a lot in the last few minutes. I will review this with you, and I will give you a line of questioning that will help you with this. So please watch this video, stop it as you need, and watch it a couple times, because this is one of those lectures that during the course of the year that I typically will sit down and spend a lot of time explaining, because this ties everything that we've talked about this year together. Everything, all the processes, this is homeostasis exemplified. It's a perfect example of anatomy and physiology, talking about the function of the nephron and the kidney. Have a good day.